Nope. We don't have a final per se. We've actually got 3 weeks of classes left. So. Okay. This is what I'm supposed to factor? Okay. So I'm going to put it in order first. I check the order first. Alphabetical, so the R's come before the S's, and then highest degree. Then I'll look for greatest common factor. So is there anything I can take out of 4R squared, 2RS, and 12S squared? All right. Then I look for my special cases. Then I look for things like perfect squares. And today we're going to do perfect cubes, so I'd look for perfect cubes. I don't have any perfect squares here. I don't have any perfect cubes. So then I'm going to do the A times C. So what factors of a negative 12 can I add to give me a positive 1? Mm-hmm. 2R squared plus 4RS minus 3RS minus 6S squared. I can pull out a 2R, R plus 2S. I can pull out a minus 3S, R plus 2S. This leaves me with a 2, R plus 2S, 2R minus 3S. Come on, there we go. You want to do one more? Okay. Yep. I'm sorry, p to the fourth. Okay. Can I ask a question? Was this p to the third? Oh, did it freeze? Hold on. What's going on? Is that the correct? 90 p to the fourth, q to the third. Can you see it now, Ryan? Something seems wrong there. You could factor a 9. Yeah, you could have. But that's all you can do with this one. But if you factored out a 3, yeah, that's all you can do with this. So if you only factored out a 3 instead of the 9, it would not have taken it. But that would have been it's a small error. In the grand scheme of things, that's a pretty little thing. There's no squares or cubes here. This would be a linear factor, meaning we have a first power. And since we have a first power, I can't break this down any further. So it would be done. All right? Okay. All right, let's look at the next section then. Next section is 6.5. And we're factoring the sum and difference of cubes. That's a little bit better. Okay. So In order to be able to work in this section, you have to be able to recognize perfect cubes. So let's talk about what some of those are right now. If I have an x to the third power, this is going to be x to the third. That is a perfect cube. If I have x squared and I cube that, that's going to give me an x to the sixth. This is also a perfect cube. If I have a y to the third power and I cube it, that's going to give me a y to the ninth. This is also a perfect cube. So, if your powers are multiples of 3, a 3, 6, 9, 12, 15, etc., there's the possibility that what you have is a perfect cube. It's fairly easy to see when we're working with the exponents and the variables. However, it's a little bit harder to see with numbers. If I have a 1 and I cube it, this is 1 to the third power. That's still going to be a 1. If I have a 2 and I cube it, this is 2 to the third power, or 2 times 2 times 2, which is 8. 3 to the third power is 3 times 3, which is 9, and 9 times 3, which is 27. 4 to the third power is 64. 5 to the third power is 125. 6 to the third power is 216. 7 to the third power is 343. 8 to the third power is 512. 9 to the third power is 729. Being able to recognize the perfect cubes that are listed here is helpful when dealing with the sum and difference of cubes. You can see that recognizing these numbers is not the easiest thing on the planet, right? I myself have found that knowing the first 5, 1, 8, 27, 64, and 125 covers about 75% of the cubes that you're going to run into when they ask you to factor perfect cubes. So just knowing these first 5 is a great help. All right. The first situation we want you to be familiar with is something called the sum of two cubes, or the sum of cubes. And the sum of cubes is a pattern where you have a cube added to a second perfect cube. This is simply the sum of two cubes. The difference of cubes is the same, except we're not adding them, we're subtracting them. Sorry? This is m squared to the third. Any power of 3 or any multiple power of 3 will be a perfect cube. So the third power, sixth power, ninth power, 12th power, etc. There are two factoring patterns we use here. For the sum of cubes. You will have the first number cubed plus the last number cubed. This is equal to f plus L times f squared plus FL. What's opposite? Plus L squared. The difference of cubes will have the first term cubed minus the last term cubed. And that will equal the first minus the last times the first squared plus the first times the last. First times last plus the last squared. Okay, let's try some. All right, here we have x to the third minus 27. X to the third is an x cubed. 27 is a 3 cubed. So this would equal the first minus the last, x minus 3. Notice I'm using the cube root, x minus 3. The sign is staying the same as what it was. Then it's the first term squared, or the first root squared. The sign will be the opposite of what was there. Then we do the roots multiplied together. The last sign is always positive. And then we add the second root squared. The terms follow the cube roots. The signs go by a general acronym that you sometimes hear called SOAP. It's the same sign that was here, the opposite sign that was here, and then the last sign is always positive. You see the word SOAP there? Questions for me? The cube root of 27 is 3. The cube root of x cubed is x. The 3x comes from multiplying the cube roots together. Okay? All right. So if you have to factor k to the 6th plus 125, this is only 2 terms. Recognizing that the 6th is a multiple of 3, I could rewrite this as k squared to the 3rd power, and 125 I know is 5 to the 3rd power. I use the first cube root plus the second cube root, keeping the sign the same as the original. My second factor squares the first cube root. The sign will be the opposite of what's here. Then I multiply the 2 cube roots together. The last sign is always positive, and it's the square of the second cube root. It's the first cube root squared. So k squared to the 2nd power. Two times 2 is 4. The sign is opposite what it was. Then it's the cube roots multiplied together. So 5 times k squared. The last sign is always positive. And then it's the cube root squared. I have two terms with a difference. Since this is a to the third power, I recognize this as an a cubed. Since this is a b to the third power, I recognize it as b cubed and 8 as 2 cubed. Following the pattern, it's the first cube root minus the second cube root, noting that the sign stays the same. Then it's the first cube root squared the opposite sign from the original, multiply your two cube roots together. The last sign is always positive. And then it's going to be 2b, or the last cube root, squared. 2b times 2b is going to be a 4b squared. Questions? Austin, anything from you? Okay, Summer? Did I lose you yet? Okay. All right. Ryan, you still doing okay? All right. Let's see if we can do these 4. Okay. What do you notice about this first one? So the first thing we're going to do is pull that negative out. So whenever it leads with negative, they want you to pull that negative out first. So we're going to go ahead and do that. Now, x to the third is a perfect cube. So I want to check and see if 216 is a perfect cube. I've got a list, but if I don't know my list, your cube root is going to be in this first row here on my calculator. It's right, that green one right, oh, can't see me. It's that green one right there. I have to hit 3 and then 216. And that's going to tell me that 3 in front tells my calculator to look for the cube root of 216. And it tells me that that's a 6. So I know that this is an x cubed minus a 6 cubed. Using my pattern, this is going to be a negative first cube root minus last cube root times first cube root squared. Then it's those two multiplied together with the opposite sign. And then the last one squared. 6 squared is 36. And the last sign is always positive. The signs, again, are going to be same, opposite, always positive. Spells out soap. Cube root. Okay. So in the first column, above the chevron key, so since I need the third root or cubed root, I'm going to hit my 3 first, then second chevron, and then 216. That 3 tells my calculator I'm looking for the cube root of 216. Okay? All right. Okay, example 5. Is there anything we can pull out of both of those terms? 8 can get pulled out. Anything else? 8x can get pulled out. And then I'm left with 8m cubed minus 1. M cubed is a cube, so this is going to be 2m cubed. 1 is a cube, 1 cubed. Eight x comes out front. First minus last. Then the second factor is the first one squared with the opposite sign. The first times the last, always positive, last squared. The last cube root squared. We look at example 6. Is there anything you can pull out? So that'll be an x to the third. Yep. 216 y to the third. These are cubes. So this will be an x to the third. And 216, I think we did. That's a 6y. I was going to say, I thought I was hearing something. It's the first Monday of the month, isn't it? Yeah. Okay. So that's just their check. No need to panic. All right. So I've pulled the xy out. It's the first cube root, in this case, plus the last. Then we take the cube root and square it. We use the opposite sign. Then it's the two roots multiplied together. Always positive. And then the last root squared. So 6 times 6 and y times y. So far, so good? All right, last one. Can I pull anything out of 125p cubed and 64q to the ninth? Nah. But p to the third is a perfect cube. Is 125 a perfect cube? So it's going to be a 5p cube. Is 64 a perfect cube? There you go. What about q to the ninth? Not 2, but it's q to the third. Okay. Oh, goodness gracious. All right, the first one minus the last one. So 5p minus 4q to the third. Then we need to do the first one squared. So 5p times 5p. 25p squared. Opposite sign. Multiply together. 20p q to the third. Always positive. Square this last one. 4 squared is 16. Q to the third times q to the third would be q to the 6. Okay. Now here's something we didn't check, but comes out important. So you notice every time we did a sum or difference of cubes, I never tried to break down the second factor. That's because these second factors, this x squared plus 6x plus 36, and the x squared minus 6xy plus 36y squared, and the 2m squared plus 2m plus 1, and the 25, these never break down. So when you're doing the sum or difference of two cubes, that second factor can't be split apart any further than it already is. So once you've reached that part, you're as far as you can go. All right? All right. Anything else from me today? Okay. Some are pretty good. The homework on this section is just practicing with this pattern. Tomorrow and the rest of this week, we throw everything all together. But today is just practicing with that. Tonight's homework is just practicing with that one pattern. It is, yep. Yep. So practice and get this pattern down, and then the rest of this week we'll talk about when everything's all together, like what are some strategies in particular for knowing what to use when. Okay? All right. That's all I got for you today. You guys too. Thanks. Take care.